Welcome to Alpha G Educator channel. Today we are going to look at how to solve problems involving SURDS. We focus more on what simplification of what SURDS. Now, the first one we are going to consider today is the rules of what SURDS. Rules of SURDS. Now we have the multiplication rule and the what division rule. The multiplication rule, which is if you have root AB, this is equal to root A times root B. And if you break it down further, it is root A times root B. Example, e.g., root 6 can be broken down into root 3 times root 2. Root 3 times what? Root 2. Right? So, this is for the multiplication. We have the one we use for division rule. Division rule. So if you have root A over B, this is equal to root A divided by root B. So if you have something like root 6 over 2, this is something as root 6 over root 2. So take note of the rules of what SURDS. So we call this the multiplication rule, and we call this one what the division rule. So the next thing we are going to look at is how to simplify SURDS. Simplification of what? SURDS. Simplification of what? SURDS. Simplification of SURDS. Assuming you are asked to simplify square root of what? X. Now to simplify this, you are going to break it down into one perfect square and one basic surd. So this can be broken down into a perfect square times a basic surd. A basic what? Surd. So take note of this. Anytime you are asked to simplify any surd, you must break it down into a perfect square and what? A basic surd. Now we are going to look at examples of perfect square and some examples of what? Basic surds. Examples of perfect squares. Examples of basic surds. Examples of perfect squares are root 4, root 9, root 16, root 25, root 121, root 144, root 36, and so on and so forth. We have many others, right? So these are examples of what? Perfect squares. So when you take the square root of all these numbers, you get a what? A whole number without a decimal point. So we call them perfect square. Let's look at basic surds. These are surds that cannot be simplified further. You cannot break them down further. Example, root 2, root 3, root 5, root 6, root 7. Somebody will ask, how come root 6 is a basic surd? Yes, root 6 is a basic surd because root 6, you can only break it down into root 3 and what? root 2. You cannot go beyond this. And p is still the same thing as root 6. You have not done anything, you have not changed anything. So root 6 is a basic surd. Because you cannot simplify it more than this. What about root 8? Root 8 is not a basic surd because root 8 can be simplified into root 4 times root 2. So once you can simplify into a perfect square and a basic surd, it means that that surd is not a basic surd. And the target is for you to simplify it into what? Its lowest term. So this will give us what? Square root of 4 times square root of 2, which is equal to 2 root 2, or 2 times root 2. So you can see that 8 is not a basic surd. Rather, 8 can be simplified further. So root 8 is the same thing as what? Root 2 root 2. 2 root 2 is a basic surd. So we can add 2 root 2, 2 root 3, 3 root 5, and many others. And many others. Right? So you must understand this. So if you want to understand problems involving surds and how to simplify them, how to break them down, you must follow this rule. You must do what? Follow this what? Rule. Now let's solve some examples. Example. Simplify the following. I. Let's take a root 12. Root 1 to 5. Zero point 0.04. Root 54. X raised to the power 5, y raised to the power 3. Right? Root 726. Root 726. Root 726. Okay, so we are going to look at the solution. Let's look at the solution. Starting from I. We have square root of what? 12. Square root of what? 12. Now remember the rule. One basic surd, one perfect square. So the perfect square that you can find inside of 12 is what? 4. And the basic surd is what? 3. Right? Now, this will give you, we are now applying the multiplication rule of surds, which is root 4 times root 3. So this will give us 2 root 3, or 2 times square root of what? 3. Now, this is the method. Now, if you don't follow the rule of using one basic surd and one perfect square, this is what you are going to obtain. Method, or let me call it the wrong method. Wrong method. Wrong method. So you have root 12, which is equal to, now you fail to obey the rule of one basic surd and one perfect square. You now break it down using root 2, root 6 times 2. Look at the problem here. The problem here is that this is a basic surd. And this is also a basic surd. Can you see it? You cannot simplify it more than this. But look at this one. This is what? Perfect square. This one, basic surd. You can see the difference. Perfect square, basic surd. Why this one? Basic surd, basic surd. You cannot go more than this. The highest you can do is this. So the highest you can do is root 6 times root 2. That is all. And you are stuck. So this is wrong. This is not how to simplify root 12. So this one is what? Correct. So know the difference now. So stick to the rule of what? One perfect square, one basic sum. So let's look at the next question. I. So we have root 125. Now we're going to look at the factors of what? 125. What are the factors of what? 125. If you look at the last digit here, it is divisible by 5. So you have 5 and what? 25. This one is a perfect square. This one is a basic sum. So you can proceed. 25 times 5, which will give us root 25 times root 5, which will give us 5 root 5. Now, our example 3, we have root 0.04. So whenever you see a problem like this, your first target is to convert this decimal point that you have there towards a proper fraction. So this will give us root 4 over 100. So remember our division rule of SURDS. So this will give us root 4 over root 100. So which is equal to 2 over 10, which is 0.2. I hope that is taken. Now we'll move to the next one. So our IV, we have root 54 x raised to the power 5 y raised to the power 3. So this is equal to root 54 times root x raised to the power 5 times root y raised to the power what? 3. Now remember the rule. We are going to break 54 into what? A basic sum and a perfect square. So let's look at the factors of 54. The last digit here is divisible by 2. So you say 2. 2 divided by 54 will give you what? 27. Now you cannot work with this. You cannot work with 2 times 27 because 27 is not a perfect square. 2 is not a perfect square. So you are going to break this 27 down again. This 27 is divisible by 3. So you are going to divide this by 3 and multiply this by 3. So if you do that, this is what you are going to get. 2 times 3 will give us what? 6. 3 divided by 27 will give us what? 9. 9 times 6 will still give you what? 54. And 9 is a what? A perfect square. 6 is a basic sum. So this will give us root 9 times 6 times this x raised to the power 5. You break it down into a perfect square, a power that is a perfect square, and a power that is a basic sum. That is x raised to the power 4 times x raised to the power 1. Same thing applies to y. You break it down into a power that is divisible by 2, a perfect square, and a power that is a basic sum. A power that is divisible by 2, rather. See, this is y raised to the power 2 times y raised to the power 1. Right? So that's what we call, let's call it the fractional index law. If you have root x, it's the same thing as what? X raised to the power 1 over 2. So we are going to use it for this. Let us take this part first. So this one will give us root 9 times root 6 times root x raised to the power 4 times root x times root y raised to the power 2 times root y. Now let's take this root x raised to the power 4 is the same thing as what? X raised to the power 4 raised to the power 1 over 2. So this 2 here will cancel this 4. So we have what? X raised to the power 2. Same thing applies to y. So we'll do the same thing for y. Take note of this, very important. We call this the fractional index law. So if we simplify now, this will give us 3 root 6 or times root 6 times this, we take this, we have 2 x squared times root x. This, we take this, we have 1. We have y times root y. Right? So if we break it down further, we have 3. So we have root 54 x raised to the power 5 y raised to the power 3 is equal to, you take the whole number first, 3 x squared y. 3 x squared y. Then for the roots, you have root 6, root x, root y. Root 6, root x, root y. So if you simplify this, you will get this. How that is taken? Very simple. Okay. Now, the last one, v. V. We have for v, we have 4 root 45. 4 root 45. So this will give us 4 root 9 times root 5. Okay, let me show you how to break down the 45. Let's look at factors of 45. This last number here is divisible by 5, so you say 5. So 5 into 45 will give us what? 9. So 45 is something as what? 5 times what? 9. So this will give us 4 times root 9 times 5. So this will give us 4 times root 9 times root 5. So this will give us 4 times 3 times root 5, which is equal to 12 root 5, or 12 times root 5. All this is taken. Very simple. Okay? Alright. Alright, so we're going to solve more examples. But this time we are going to solve numbers that are a bit larger. Right? 175, 726, and 288. How do you simplify these numbers? So you can even simplify numbers that are higher than this. Right? You are going to follow this simple step. So we say solution. Solution, right? So we have I. Want to simplify 175. 175. Right? So that is taken. So you bring out, let's look for the factors of 175. You consider the last digits. The last digit is 5. So it means that this number is divisible by 5. So you put 5 here. 5 into 175 will give us 35. Right? 35. Okay. Now, we cannot solve with this because this is not a basic sum. This is not a perfect square. This is a basic sum. This is not a perfect square. So you need to break it down again. Now, if you look at this number here, the last digit there is also divisible by 5. So you are going to multiply this one by 5 and divide this one by 5. Let's see how it will look like. So 5 times 5 will give us what? 25. Right? Now, 5 into what? 35. What do you think we are going to get there? 5 into 35 will give us what? 7. Can you see it? 7. Now, let's check. This one is a perfect square. This is a basic sum. Can you see it? Alright, so we are going to do it like that. So we break it down now into 25 times 7. So, if we simplify it now, we are going to get what? Root 25 times root 7. Okay? So this is what? 5 root 7. So let's look at this one. I. Root 726. Right? So you bring out, let's look for the factors of what? 726. Now you go again, the last digit here is divisible by 2. So you put 2 here. So into this, we give us what? 3, 6, 3. Now can we work with this? Can we work with this? Not sure. we cannot work with it because this number is not a perfect square. So we break it down again until we obtain what? A perfect square. How do you break it down? What is the last digit? 3. It means that this number is divisible by what? 3. So we are going to multiply this one by 3 and divide this by 3. So let's look at what we are going to get. So this will be what? 6 and what? 121. 6 times 121 will give us what? 726. So we are going to change this to root 121 times root 6. So which will give us what? Square root of 121 times square root of 6, which will give us 11 root what? 6. Simple? Simple. Alright. Now for the last one, that one is very simple and very straightforward. We have I is root 288. Right? So now let's look for the factors of 288. 288, the last number here, the last digit here is divisible by what? 2. So 2 into 288 will give us what? 144. We don't need to go any further because 144 is a perfect square. So we are going to break this into 144 times 2, which will give us 144 times root 2, which is 12 root 2, which is what? Which has been simplified what? 288 has been simplified to what? 12 what? Root 2. I hope you enjoyed the class. Always remember to subscribe to our channel. So this is how to simplify salt. It doesn't take 10 minutes, you are done with simplification of what? Salt. So I know that you enjoyed the video. Always remember to subscribe and like our channels for you to be able to enjoy more videos like this. See you soon.